These will be tightened to original specifications later with a torque wrench, and new cotter pins will be installed. Having installed our front springs, we can now attach the front struts to their brackets and to the lower control arms. The rubber bushings have been inspected, and if necessary, new bushings can be purchased from our local Ford parts department. The threaded ends of the struts at the rear are inserted through the holes in the strut brackets that were previously bolted to the chassis. After placing the rubber bushing and metal washer on the end, the original Ford nut is installed. The two studs at the front of each strut passed through the mounting holes in the lower control arm. We thread the original nuts on and then tighten them with the necessary tools. Our front suspension is almost complete. When we disassembled our donor car, we decided to replace the original front shocks. New units were purchased from our local auto supply store. They are direct Pinto replacements and were very reasonably priced. We insert the shock absorbers up through the lower control arm, guiding it through the center of the spring. The original Ford bolt is installed, passing it through the lower control arm and shock mount bushing. It is then secured with the original nut. We place our floor jack under the lower control arm and compress the spring assembly enough to allow us to pass the upper mounting stud through the mounting hole. It is located in the center of the spring mounting recess of the crossmember. New hardware was supplied with our shocks, and we slip a rubber bushing and metal washer on the end of the stud. The nut is then threaded on, and we will use the appropriate tools to tighten the shock hardware. We lower the floor jack and repeat the same procedure on the other side. In order for us to connect the steering column to the rack and pinion assembly, we need to fabricate an extension, as the original Ford column is too short. The manual we are using shows an earlier way of fabricating the extension. They have since developed a new method of making the extension. A complete unit, welded and ready for installation, is available from the manufacturer. Otherwise, we obtain a 30-inch length of solid steel shaft and cut it into two pieces. One piece is 14 inches long and the other is 16 inches. The end of the 14-inch piece is machined to fit into the end of the Ford universal joint, where it is pinned in place with the original Ford bolt. A top-quality pillow block with a 3/4-inch bore, along with a 3/4-inch universal joint, complete our assembly. The two lengths of shaft are pinned and welded to the universal joint. Here we have our completed extension ready for installation along with the Ford universal joint. The end of the extension has been properly machined to fit into the opening of the Ford universal. When properly located, the original Ford bolt pins the shaft securely in place. Before we can fit our new extension to our chassis, we must bolt the Ford universal to the rack and pinion. We have thoroughly inspected the rubber coupling disc. If it were worn or loose, we would replace the entire unit, as the coupling disc is riveted to the flange of the universal. We slide the flange at the lower end of the universal onto the splined shaft of the rack and pinion and secure it with the original Pinto hardware. Later, we will use a torque wrench to tighten this bolt to original specifications. Our steering extension can now be positioned in place. We slide the upper end of the extension through to the passenger compartment and into the steering column shaft. We have placed the pillow block bearing on the lower shaft, and we insert the machined tip correctly into the end of the universal, using the original bolt to hold it in place. Next, we slide the pillow block bearing into position against the frame mounting support plate that is part of the frame. After drilling 3/8 inch holes through the support bracket, we install two 3/8 by 1.5 to 2 inch long bolts and secure with flat washers, lock washers, and nuts. The nut is installed on the bolt that secures the forward universal to the extension. All bolts are tightened fully. We drill a hole through the steering column and extension inside the passenger compartment and secure the column to the extension with a 5/16 inch grade 8 bolt. Before we drive our new car, we will have this joint welded. Moving to the rear of our chassis, we'll be installing the emergency brake cable next. A support bracket is welded to the frame below the rear link mount. In order for us to install the cable to the new bracket, we must cut the cable about 4 inches from where it exits from its protective housing on the passenger side. After the cable has been cut, we remove the retainers, along with the old brackets that secured the cable to the underbody of our donor car. Each end of the cable passes through a hole in the new mounting brackets and is secured with the retainers. We pull both ends of the cable together and install two 1/8 of an inch wire rope clips to secure the ends together. For now, we do not fully tighten the nuts. After our emergency brake lever has been installed and we've adjusted our brakes, we'll tighten the nuts securely. For comparison, we have placed two floor liners side by side, since we need to do some preliminary work before we can install it on our chassis. Using a China marker, we mark the holes and scribed area that we will need to remove for our shift lever. The hole for the emergency brake rod along with the mounting holes are marked next. At the front of the floor liner, we mark a hole to the left side of the transmission tunnel for our speedometer cable. We also need to make a notch for our steering column. This location was determined by placing the floor in its approximate position on the chassis. After making a 3/8 inch pilot hole, we use our electric saber saw to cut out the opening for the shift lever assembly. A rotary rasp is used to enlarge the holes for the speedometer cable and emergency brake rod. Once our cutouts have been made, we can install our shift lever assembly and emergency brake lever. Four 5/16 inch by 1 inch long bolts with flat washers, lock washers, and nuts are used to secure the shift lever assembly to the floor. The emergency brake handle assembly is placed in position with the rod extending through the hole at the rear. We secure the handle assembly to the floor with two 5/16 inch by 1 inch long bolts, along with flat washers, lock washers, and nuts. The rubber boot on the emergency brake rod is used to seal the hole in the floor recess. The wiring harness can be installed at this point. We secure it to the inside of the main frame rail on the left side. We can just as easily do this later on if we wish. Rubber matting used for stairway tread was obtained from our local home center. A utility knife was used to cut the matting into appropriate lengths and widths so we can cover all frame surfaces that come into contact with the floor liner. This will prevent squeaks or rattles from occurring between the pieces. 3M 1300 rubber adhesive in a convenient tube is used to cement our rubber strips in place. The floor liner can now be placed on our frame. We simply slide the liner in from the rear, elevating the rear so the front lip clears the brake pedal. We have temporarily disconnected the push rod from the brake pedal to make the job easier. The notch we made earlier provides clearance for the steering column. We push the floor down and into position. When necessary, we can stand on the floor, using our weight to push it all the way down against the frame. We use gloves during this procedure to protect our hands. Referring to our instruction manual, we mark all mounting hole locations. Our electric drill, along with a 3/16 inch bit, is used to make the 16 holes through the floor liner and top frame surfaces. Either heavy pop rivets or 1/4 inch by 3/4 inch hex washer head self-tapping screws are used to secure the liner to the frame. After this has been done, we connect the shift lever rod to the transmission and shift lever and place the emergency brake yoke on the adjustment rod and attach the cable. Two 3/8 inch holes are drilled in the rear of the battery box, and our accelerator pedal is bolted in place with 5/16 inch by 1 1/4 inch bolts with flat washers, lock washers, and nuts. The accelerator pedal position can be altered for driver preference. Our rolling chassis has been completed. The original tires have been retained and will be used for most of the assembly. When our new MG TD Replica is completed, we will mount custom wheels and new tires. At this point, our chassis is ready for the new MG TD body, which we are preparing. It will fit right in place. Installation of a battery along with a few electrical connections in the engine compartment would allow us to start the engine. But first, we are going to give the entire chassis a good coat of gloss black enamel paint. We prefer gloss enamel to a flat paint. It's easier to keep clean, and we find it's generally more durable. We will remember to recheck everything and torque all necessary bolts to original factory specifications before running the new vehicle. Also, we will have the car thoroughly inspected, the front end aligned, and make any other necessary adjustments to meet all safety and emission requirements before the car is driven. We can now congratulate ourselves on a job well done.